Hello all and welcome to the Math 8 video for inequalities. In this section we're going to talk about inequalities, which are kind of the counterpart to equations. If you remember, with equations we had two things or two sides that were equal. Well, when we talk about inequalities, emphasis on the prefix here of in, well, what we've got here are things that are not equal. Okay. So in this case, inequalities in math refer to things that are not the same, meaning one side's bigger than the other. Okay. So with that being said, we do need to talk about some inequality symbols. Now, for most people, this will be kind of a review because this is stuff that at this point maybe should have seen somewhere, okay? But if you haven't, definitely pay attention to this part because there are certain symbols that we use, and we need to talk about kind of what they mean here. So the first thing we have here is the less than symbol, and the less than symbol is just a kind of like a bracket, a sharp bracket that opens to the right-hand side. And the reason we call this a less than symbol is that whatever is on the left over here, whether it be a number, expression, variable, whatever it is you have over here, it's always going to be less than whatever's on the right. Okay? So we have less than. Well, if we have it flipped around and whatever's on the left is bigger than whatever's on the right, that's when we use the greater than symbol, which is just the left or the less than symbol just flipped around. Okay. And once again, what that means is whatever's on the left over here, whether it be a number, variable, expression, term, whatever it is that you have over here, you will have it be bigger, so it's bigger than whatever's on the right. Okay. Now, in addition to things being less than or greater than things, other numbers or variables, we also can talk about things that are less than or equal to. Okay. So if you see the first part here, it says less than. Well, we use the less than symbol for the less than or equal to symbol. But there's one extra thing that has to go with it. Okay. If we just left it like that, these two signs are actually the same. It doesn't really tell us anything. But if we want to be less than or equal to, then what we do is we put a line underneath the less than symbol. You can kind of think of this line as like half of an equal sign. So if you think of an equal sign, it's two dashes or two lines over top of each other. You can kind of think of a less than or equal to sign being like the top of the equal sign being converted into a less than symbol. Okay. And then same thing with the greater than or equal to. If we need greater than or equal to, then we take the greater than symbol and we put a line under it, meaning greater than or equal to. Okay. So what we mean by this is, well, whatever number we have on the left has to either be less than or it can possibly be equal to whatever's on the right-hand side. And the same thing with the greater than is whatever's on the left can be greater than, but it could also be equal to whatever's on the right. Okay? And you'll see what we mean by that when we look at some of these, when we need to graph and when we need to really understand what it means for something to be less than something else or greater than something else. But then there's two other symbols we've got to talk about, and these pertain to specifically what we are going to use when we graph. Okay. So just like an equation, we can technically graph equations. Well, we don't have to graph equations to figure out what their answers are. But in a way, in order to figure out what all the answers are to an inequality, we sometimes, or most of the time, we will graph our inequality. So with that being said, if we have to graph an inequality and we have a less than or a greater than symbol, we actually use the same notation here, the same symbol, which is an open circle. Okay. And you'll see what I mean by that. If that's confusing to you, what I'm talking about here, you'll definitely see it in the next section when we actually go to graph inequalities. See what I mean by using an open circle. But at the same time, if it's less than or equal to or greater than or equal to, then we actually use a closed circle, meaning it's a circle that where it's filled in. Okay, so and this is what we call a closed circle. Okay. And the way I like to describe it is if you've ever taken a test where you've had to fill in a circle or fill in an oval to give your answer. Well, this is kind of the same kind of principle in that if it's less than, well, that means the numbers on either side can't be equal to each other. So whatever's in the middle here, it's not going to be an answer. Okay. Same thing with the greater than symbol. But if it can be less than or equal to whatever number's in the middle, so whatever number we're talking about, it can possibly be an answer. So it can be equal to the other expression or number or whatever it is that you're talking about. Okay. So like I said, you can kind of think of it as if it's filled in, it can be equal to. If it's not filled in, it can't be equal to. Okay. And let me show you what I mean by that. So let's go ahead and look at some examples. Okay. So the first 6 examples here are all about graphing inequalities. And we can really get our first look at what an inequality really means. So, first inequality we have for number 1 is x is greater than -8. Okay. So the first thing I notice here is my variable's x. And in this case, we're talking about a variable because we want to say, well, there's a number, or actually in this case, a lot of numbers that are bigger than -8. Well, what numbers are bigger than -8? Well, if you're looking at a number line, the first thing you'll want to do is right in the middle of the number line, put the number that's in question here. So x is greater than -8. Put the -8 right in the middle. Okay. So after that, fill in the rest of the number line. And with the negatives, you do have to be careful. Okay. So I probably have a few more spaces than you do on your paper there, but fill it in as much as you can. So in this case, -8. Technically, to the right is -7, -6, -5, -4, -3, and so on and so on. To the left is -9, -10, -11, -12, -13. Okay. So all we're doing here is labeling the number line. This is just a general old number line like you're used to from before. And then the next thing to notice here is x has to be greater than -8. Well, I'll ask, can x be equal to -8? So if we put 8 in here, is it true that 8 is greater than, or -8 is greater than -8? And that's actually not true. So this is what leads us to know that we need to put an open circle here. Okay. So this is what I'm talking about with the open circle here. If it's greater than, strictly less than, or strictly greater than, okay, then you have to use an open circle. And then you just ask, well, which way are the numbers bigger than -8? And in this case, they are bigger to the right over here. So that means we draw an arrow to the right. Okay. So what this tells us is there's actually an infinite number of answers to this inequality. Because what are some numbers that are bigger than -8? Well, -7, -6, -5, -4, -3. All these numbers over here, plus all the rest of the ones that you don't see that are to the right of -8. So things like 0 and any positive number. So 1, 2, 3, 4, 5, 6, 7, 8. A million, okay, 297,467, okay, whatever number that you can think of, Things like 1/2, 2/3, okay? Any number that you can think of that is to the left of -8 is an answer, okay? But notice, since we did the open circle here, this -8 is actually not an answer because -8 is not greater than -8, okay? And that's pretty much all there is to graphing inequalities. So let's look at number 2. We have k is less than or equal to 5. Well, same kind of thing. K is our variable in this case, but we want to know what numbers can go in here. What numbers are less than or equal to 5? Well, once again, go to the middle. You're going to have 5 and then fill out the rest of your number lines. 6, 7, 8, 9, 10, 4, 3, 2, 1, 0. Okay, once again, you might not have as many spaces here, but just fill out what you can. And then we go and do our same thing we did over here. We ask, can k be equal to 5 in this case? Well, in this case, actually, yes. So this is where we would use a closed circle, okay? So basically a closed dot or a open circle that it's filled in, okay? And what that tells us is if this open or closed dot is above the 5, that means 5 can be an answer. Because if we put 5 in here, 5 is less than or equal to 5. It's not less than 5, but it is equal to 5. And once again, that's why we use a closed dot to say 5 can be an answer. But then the last part is, well, what direction are all the numbers less than 5? In this case, that means the arrow would go to the left this time. And to check yourself and make sure that you did it the right way, pick a number that's over here. Let's pick an easy one. Let's pick 0. Well, is 0 less than or equal to 5? Well, 0 is less than 5, so it is less than or equal to 5. Okay? So the way that we drew the arrow is correct. Notice if we pick something else over here, so let's say we pick 10, well, 10 is not less than or equal to 5. So that kind of gives you a check to say, well, hey, did I put the arrow the right way? Because if you pick a number from either side, the side the arrow should be pointing to should give you the answers, or the numbers over there should give you something that's true. All right, so I do say if you wanted to take a second and work the next couple on your own here, so numbers 3 and 4, do suggest maybe pausing the video, trying these yourself, and then coming back and checking to see if you did these correctly. Okay, but like I said, we'll give it a second to pause here, but then let's go ahead and get on with these. So if we look at number 3, variable in this case is m, and we have m is less than -3. So once again, very first thing you should do here is right in the middle, let's put a -3, because that's where we are on the number line. That's where we're looking. So to the right, we have -2, -1, 0, 1, 2, and so on. And to the left, we have -4, -5, -6, -7, -8, and so on. All right. So with all that being said, that's where we are on the number line. Well, let's do what we did before. Can m be equal to -3? Well, it can't. So we have an open circle. In the direction where all the numbers are less than -3 is to the left. Okay. Number 14, exact same thing. Start off in the middle with 14. Then to the right, you have 15, 16, 17, 18, 19. To the left, you have 13, 12, 11, 10, 9, and so on. So we ask, can P be equal to 14? Well, in this case, yes, it can be. So we're going to use a closed circle. And then the direction where all the numbers are bigger than 14 is to the right. And that's just a good rule of thumb to remember, is numbers are always bigger to the right, numbers are always smaller to the left. And that's a very fundamental thing to know with these, is because that tells you which way you need to draw your arrows. Okay? But really the steps here are fill out your number line, determine if you need an open circle or a closed circle, and then draw your arrow appropriately, meaning look and see, well, what numbers do we need? We need numbers that are bigger than -8. We need numbers that are smaller than 5. We need numbers that are smaller than -3. And we need numbers that are bigger than 14. Okay? Now the next two, numbers 5 and 6, are a little bit tricky. So if you look, you can maybe tell that these are a little bit different than the ones we just did. Here we have the variable on the right-hand side instead of on the left-hand side. But the principles are still the same, is that what do we need? Well, we need 7 to always be bigger than whatever number we have for p. Now, there is a thing we can do. So if we go over here, we can actually rewrite this as p is less than 7. But you have to be very aware that the reason we can do this is we have 7 is greater than p, meaning the greater than sign opens up to the 7, meaning 7 is always going to be bigger than p. Well, if that's the case and we move p to the other side, that means the whole sign has to flip as well. So it has to still open up to the 7. So if we flip the sides and put the p on the left and the 7 on the right, the sign has to flip with it. Okay. So if you do that, then it works just the same as what we did before. But you technically don't have to do that. You can still think about it from here and say, well, what numbers do I need? I need numbers around 7. So we'll go ahead and put 7, 8, 9, 10, 11, 12, 6, 5, 4, 3, 2. And we say, well, can p be equal to 7? In this case, it's no. And we just got to think, okay? And either way, it works the same, but we got to think, well, what kind of numbers do we want for p? Well, we want numbers that are smaller than 7. And the numbers in this case are smaller than 7 to the left. Okay? And once again, that tells us that any number that you pick over here, so a big one that you might notice is zeros over here. And if you plug 0 in either one of these, it will be true. 7 is bigger than 0, and 0 is smaller than 7. So both of these things say the same thing. Okay? So if you wanted to, same as before, maybe give number 6 a try here based on what we just talked about. So if you need to, pause the video, go ahead and do that, and then come back and we'll do this one together. But if we look at number 6, -2 is less than or equal to n. Well, that means -2 is always less than, or it could be equal to n. That means n has to be bigger than or equal to -2. And that's exactly what we can write if we want to write it like we're used to here. So, but we do have to remember, if 2 is less than or equal to n, that means n is greater than or equal to -2. Okay? So either one of these will work. Just make sure you understand what this means in saying, okay, well, we're going to start at 2. So let's do 2, 3, 4, 5, 6, 7, 1, 0, -1, -2, -3, and so on. Well, we're going to start at -2. Oops. See, I about messed up there. I messed up my numbering. I started at 2 and not -2, which is fine because -2 is still on our number line, but it's good to try to focus on where exactly you are on the number line. So here's -2, -1, 0, 1, 2, 3, -3, -4, -5, -6, -7. So we're going to start at -2. N can be equal to -2, so we're going to use a closed circle here. And in this case, we want the n's to be bigger than -2. And we can see it here, n is greater than or equal to -2. So since it's equal to, we use the open or closed circle. And then we want the numbers that are bigger than -2, and those numbers are all found to the right. And like I said, you could just pick any number that's underneath that arrow pretty much, and it will be an answer to your inequality. So -1, 0, 1, 2, 3, on and on and on until, and not can't go to infinity, but just keep getting bigger and bigger and bigger numbers. So you get a million, a trillion, a billion. Any number that's over here. That includes things like 1/2, 1.5, 2.5, 3.5. All these numbers that are on this number line are answers to the right of this of -2 are answers to this inequality. Okay. So with that being said, that's pretty much it for graphing inequalities, which is something you're going to have to know how to do here in just a few. But now let's go ahead and go talk about translating inequalities. Okay. Now, translating inequalities, much like we've done before with translating expressions, is a process of going through and taking something that is written in words and translating it into what we would consider math. So symbols, variables, numbers. Okay. So if we look at number 7, it says a number is less than 4. Well, in this case, a number is less than 4. Well, we don't know what this number is. It just says a number. So what number are we talking about? Well, let's call it X. Or you can call it N, or you can call it LMNOP. Like, you can call it whatever you want to. Okay, I'm just using X because X is a generic variable to use in a situation like this. But here we just literally read it. A number, so that's what X that we have, is less than 4. Is less than 4. Okay. So in this situation, that's exactly what it's saying. If we read this out loud and think about ourselves, we would say X is less than 4. So it's saying the exact same thing as what they have in words up here. A number X is less than 4. So to graph this, we do the same thing. We'd start at 4. Label our number line here. So we're going to start at 4. In this case, we would have an open circle because X has to be less than 4. It can't be equal to 4. Okay. And then we want the numbers less than 4. Those numbers are found to the left. So once again, pick any number from over there. The big one you see is 0. So 0 is definitely less than 4. 3 is less than 4. 2 is less than 4. -50 is less than 4. Okay. The only thing is 4 is not an answer. So if you try to plug in 4, 4 is not less than 4. Okay. And that's pretty much all there is to it with translating inequalities. We're going to look at a few more examples here, especially numbers 9, 10, and 11, because they use some words that you've probably seen in real life or had to think about in real life. But let's go ahead and look at number 8. A number is greater than or equal to -18. Well, once again, a number, let's call it X, is greater than or equal to. So in this case, greater than or equal to, that's this symbol. A number X is greater than or equal to -18. And once again, just reading that expression, it tells us basically word for word what we need to write down with our symbols. Okay. A number X greater than or equal to -18. So the same thing happens when we go to graph this. We'll start at -18. You have -17, -16, -15, -14, -13. Then you have -19, -20, -21, -22, -23. And then we ask, can X be equal to -18? Well, in this case, yes, it can. So we use a closed circle. And we want the numbers that are bigger than -18, and those are all found to the right. Okay. So those are two very basic examples where literally if you read, it tells you what symbol to use. A number is less than 4. A number is greater than or equal to negative 18. But then we get to ones, oh, well, looks like I missed a slide there. So let's just add one in ourselves. So number 9. A number is at least negative 2. Okay. Well, the trick to this one is we have a number. So let's go ahead and write our x. So a number, that's x. We know our other number, this other side is we're going to talk about is going to be negative 2. So let's go ahead and put a negative 2. But then we need to talk about, well, what's the sign that's going to be in between them? And here's where you have to have some kind of common sense, some kind of reading comprehension, understand what's being said here. But if a number is at least negative 2, that means it's negative 2 or bigger. Okay? So if you've ever had somebody, say something like, there's at least 10 cars in the parking lot. Well, they're saying there's 10 cars, but there could also be more. So when they say at least, it means there's a minimum of negative, in this case, a minimum, the number is at a minimum negative 2. So what that means is all the numbers have to be bigger than or equal to negative 2. Okay? So if somebody says there's 10 cars in the parking lot, there's at least 10 cars in the parking lot, then you know that they're saying that there's 10 or more cars. And then at the same time, just think about what that logically means. Now we have our inequality. X is greater than or equal to negative 2. And this number line is going to be pretty bad here because I'm just freehanding it. Usually like to have them pre-done. But we have negative 2, negative 1, 0, 1, 2, 3, negative 3, negative 4, negative 5, negative 6. So we start at negative 2. X can be equal to negative 2, or the number can be equal to negative 2. And then we have to go through and say, well, which way does our arrow go? We want numbers that are bigger than negative 2, so my arrow is going to go to the right. All right, then number 10. Same kind of idea here. We really got to read and understand what it's saying here, but it says a number is no more than 9. Okay. Well, once again, we got to really understand what it's saying here. So once again, a number is no more than 9. So our two things here are a number x, no more than 9. Okay, so 9 is our other side. Well, what does it mean when a number is no more than 9? So if somebody says there are no more than 9 desks in the classroom. Well, what they're really saying there is 9 is the maximum number of desks that are in the classroom. So there may be 9 or less. Okay? So in this case, the number that we have, if it's no more than 9, that means it can be equal to 9, but it could also be less than 9. So less than or equal to 9. And then you have the same thing where you have your number line. Start off in the middle at 9, 10, 11, 12, 13, 14. And then we have 8, 7, 6, 5, yada, yada, yada. On and on and on. Let me put my little tick marks in here so it looks the same as before. You know, it's a little bit more poorly drawn. But here we've got x can be less than or equal to. So once again, no more than 9 means it could be 9 or less. So it could be 9 or less. So that means my arrow has to go to the left. We want numbers that are either equal to or less than 9. Okay. And then the last one here of these types of questions. A number, oops, a little squirrely there. A number is at most 40. So I do want to point out all these little phrases. So is at least, is no more than, is at most. Well, what does it mean if something's at most 40? Well, once again, it's telling you, kind of like number 10, that 40 is the most of whatever it is can be. So you could be saying there are 40 tiles in the floor. There's at most 40 tiles in the floor. That means you're kind of guessing, or you're saying that the most tiles in the floor can be 40, so it's either 40 or less. So same kind of thing. We would look here and we would say a number is something related to 40. Well, if a number is at most 40, then that means the most the number can be is 40. So that means the number you have needs to be less than or equal to 40. And then you have the same kind of thing happen with this as you did in the previous example. You'd start in the middle. There's 40, 41, 42, 43, 44, and then you have 39, 38, 37, 36. So you'd start at 40. Well, this number can be at most 40, so it could be 40, but then it's also anything that's less than 40. So once again, if it's at most 40, then the maximum amount it can be is 40. It can't be anything more. Okay? So with that being said, that's all for translating inequalities. But like I said, just think about what these words mean. Use your reading comprehension. Think about what these words mean. And these phrases here, at least, no more, at most, they actually have a mathematical meaning in that, once again, you probably heard somebody say at some point, they scored at least 50 points or something. Well, what does that mean? They scored at least 50 points. The minimum amount of points they scored was 50. They could have scored more. We don't know, but it said they scored at least 50. Okay, no more than. Well, there were no more than 10 boats on the lake. Well, once again, how many boats were on the lake? Well, 10 or less. But there were no more than 10, so there weren't 11 boats or 12 boats or however many boats. And then the last one here, at most, the same as kind of no more than, is, well, the number is at most 40, meaning, once again, that's the biggest the number can be, so we need numbers that are less than 40. Okay? All right. And then we look at the next section, and this is a lot of stuff to take in, okay, especially if you're new to inequalities. Now, most of this should be review for most people because inequalities are talked about in both 6th and 7th grade math. But if you don't remember or you didn't have 6th or 7th grade math in Virginia, then this might be a little new to you. And it is a lot to take in at one time, but we're gonna hit the end of it here in just a few. But here we got to talk about solutions to inequalities. So what we're asked to do in this section is it says to state whether the number is a solution to the given inequality. Well, what does that mean? Well, that means if we look at number 12, they tell us x has to be bigger than or equal to negative 6. So x is greater than or equal to negative 6. So what it's asking here, it's saying, Is 4 an answer to this inequality? Well, how can we tell? Well, we just plug in 4. And we think, well, is 4 bigger than or equal to negative 6? Well, it's definitely not equal to negative 6, but is it bigger than negative 6? Well, the answer there is yes. So the answer to the whole question, yes, 4 is a solution to that inequality because 4 makes the inequality true. We could have also said the same thing for the number 12 or the number 11 or 15 or 1.7, okay, or 4/3. Okay, all of the rest of the answers there are answers to this inequality. And once again, that's because, well, how many numbers are bigger than or equal to negative 6? Well, there's actually an infinite amount of numbers. You can think of, like, every number that you can think of, I can think of another one, okay? So what we are doing here is we're saying, here's a number. Is it a solution? Does it work for this inequality? Okay. So number 12, the answer is yes. Number 13, n is less than 8. Well, we need to know, is 11 a solution? Well, if we ask that, then we're essentially asking, is 11 less than 8? And in this case, it's clear that that answer is no. So 11 is not a solution to n is less than 8. Okay, once again, it all goes back to knowing what these symbols mean. And then once you plug in the number, tell if it's true or not. Okay. Now number 14, this one's a little tricky because we see the fraction here. So we really want to know, is 4/3 less than or equal to 2? Well, some people might have a little bit of trouble with that because of the fraction. But my suggestion to you is, just like we did earlier in the year, just like you've probably done before, is, well, if we want to know how big or small a fraction is, or how big or small a fraction is compared to another number, we can always write that fraction as a decimal. So if we do that, then that tells us we have 1.3 repeating is less than 2. And in that case, if you know how numbers work and how decimal places work, 2 is bigger than 1. So that means 1.3 repeating is less than or equal to 2. So the answer to number 14 is yes. Okay. So my hint to you on this one is, when in doubt, and you'll see it again down here with number 17, is when in doubt, especially with a fraction, change that fraction into a decimal and then compare it with the number or numbers you need to compare it to. Okay. Number 15, this is a little tricky one. You got to really pay attention here, but we've got a is greater than 15, and we want to know, is 15 greater than 15? Well, since there's no line underneath the greater than symbol, this is actually not true. So that's actually a no. Because if we really think about it, is 15 bigger than 15? Well, no, 15 is equal to 15. But we got to, like I said, we got to pay attention here and be careful, because this is not a greater than or equal to symbol. This is just a greater than symbol. So the answer here is no. And then the last two, number 16, got some decimals here. So we want to know, is 1.7 less than or equal to negative 1.6? And if you know something about inequalities, and it's kind of something I mentioned a little bit earlier, is this one's actually really super easy to answer. You don't even have to check the decimal places. Because if you look, 1.7 is a positive number. Negative 1.6 is a negative number. And something we know about positive and negative numbers is every positive number is bigger than every negative number. So what does that mean for this? Well, we can't have a positive number be less than or equal to, or we can't have a number be less than, let alone equal to. We can't have a positive number be equal to a negative number. We can't have a positive number be less than a negative number. So the answer here, without even looking, you don't even have to look at the numbers. You can just tell one's positive, one's negative. Well, the positive's on the wrong side. The positive should be bigger than the negative. So in this case, the answer for number 16 is no. And then we have number 17, where, once again, we have fractions, and we want to know, is negative 3 halves bigger than or equal to negative 9 fifths? Now, this one is a little bit more tricky because we have fractions, so if we need to, it's the same thing as asking, is negative 1.5 greater than or equal to negative 1.8? This still might be a little tricky, so I'm going to break out a little bit of a number line here so we can really see it. So if we're going from here, which is negative 1, to here, which is negative 2, both of these numbers are in between negative 2 and negative 1. But where are they? Well, let's use the first one first. The negative 1.5 is actually right in between them, right in the middle. So that's where negative 1.5 is. Okay. Well, where's negative 1.8 in relation to negative 1.5? Well, we have to go closer to negative 2, so it would be closer to right here. So if you really wanted to figure this out, if you know where they are on the number line, they're both between negative 2 and negative 1, but then you need to know where they are in relation to each other. And in this case, negative 1.5 is to the right of negative 1.8, so that means negative 1.5 is bigger than negative 1.8. So the answer here is yes. Okay. And this is why a number line is so handy, not so much just to write down our answers, but if we know where numbers are on a number line, we can tell which one's bigger, which one's smaller. And that goes back to comparing numbers, which is something we did towards the beginning of the year. All right. But that's pretty much it for that one. So what you're going to be doing in these types of questions are, after you solve an inequality, which is what we're going to do next, okay, based on the answer, you can tell if a number should be an answer or not. And you can also tell by just looking at the graph. If the arrow points in the correct direction, that'll tell you what your answers are and what possible answers could be. Okay? But then we get to the main part of this whole section here. So everything up to this point should have kind of been maybe a little bit of review. Once again, if you don't remember it or you've never seen inequalities before, make sure you got all that rest of that stuff down, because now we're getting into solving inequalities. Okay? And the big thing to remember about solving inequalities, there's technically two things here you can see, but the first one is we use the same steps as solving equations. Okay? So everything that we've talked about in solving one-step equations, two-step equations, possibly square root equations, although square root equations and inequalities sometimes don't mix, because you'll learn more about that as you get further on into math. So you really shouldn't have to worry about square root, like having to do square root inequalities, okay, at this point. But one-step inequalities, or one-step equations, two-step equations, multi-step equations, okay, so 3 or more steps, all the same rules apply to inequalities. So we can have one-step inequalities, two-step inequalities, multi-step inequalities. But once again, every single step is the same except for this one right here. And if you get nothing else out of today's lesson, it should be this right here. And this is the big thing you need to pay attention to. If you multiply or divide by a negative number, you must flip the inequality symbol. So what do I mean by flip? Well, that means if the first symbol was a less than symbol, then to flip it, you've got to change it to a greater than symbol. So you just basically flip it around. Same thing. If it started out as a greater than or equal to symbol, well, then to flip it, you would have to change it to a less than or equal to symbol. So that's one thing to bring up here, is when you do flip inequality symbols, if they are an or equal to symbol, so like greater than or equal to or less than or equal to, when you flip it, it also has to be equal to as well. So less than or equal to or greater than or equal to, depending on how you flipped it. Okay. But what I'm saying there is that equal to has to stay, or it has to not be there if it's not there in the first place. Okay. But once again, if you multiply or divide by a negative number, you must flip the inequality symbol. Well, it's kind of hard to tell until we look at some examples here. So let's go ahead and jump into the examples, and I'll go ahead and I'll show you what I mean by what does it mean when I multiply or divide by a negative number. So what does that really mean? Well, let's go ahead and look at number 18. Here we've got 3x plus 1 is less than 10. Well, just to show you, if I got rid of this less than symbol and I put an equal symbol in there, well, that looks pretty familiar. That's just a two-step equation that we would solve the exact same way as any two-step equation we saw before. We would subtract 1, then we would get 3x is equal to 9. Then we would have to divide by 3. So we would get x is equal to 3. But here's the deal. We don't have equal sign here. These sides are not equal. At the beginning, we're told that 3x plus 1 is actually less than 10. So here's where we've got to change. So we got to change this to a less than sign. But then we think, well, from here we subtracted 1. Well, is that multiplying or dividing by a negative number? Well, no, it's not. So since we didn't multiply or divide by a negative number, the next step here, we're still going to have the same symbol. So it's going to be 3x is less than 9. And then we've got to do this one more time where this is a two-step equation and is, well, 3x is less than 9. Well, we had to divide by 3. But we divided by a positive 3, not a negative 3. So since we divided by a positive 3, it actually stays the same. So our actual answer is x is less than 3. Where, once again, you go over here and label your number line. X is less than 3 means x cannot be 3, but it can be any number to the left of 3. So 2, 1, 0, negative 1, negative 2, 1 half, okay, 2.5. All of these numbers to the left of 3 except 3 itself. So 3 itself is not an answer here. But notice here, when I divided by a positive number, so I do not flip. Okay? Because I did divide, but I divided by a positive number, not a negative number. Okay? And this is what we mean by multiplying or dividing, is in the process of solving the equation. So when you do something to one side and you do it to the other, if you multiply or divide by a negative number, then it has to flip the inequality symbol. So let's skip number 19 and go straight to number 20 because I'm going to put stars by number 20. This is the first example that we have where we actually have to flip the inequality. And let's see why. Same kind of thing. I can replace this less than symbol with an equal sign, but let's just go from here. Once again, treat that as an equal sign and say, well, how do I solve this? Well, I would subtract 22. We get negative 2y. Okay, and then over here we get negative 4. So as we go down, once again, all I did in this step was subtract 22, which isn't multiplying or dividing at all. So in this case, we don't have to worry about it. We just keep the sign the same. But the next step, this is where we have to be careful and pay attention, is, well, what's my next step? Well, it's going to be dividing by negative 2. Well, I divided by negative 2 here. That gives me the y. Negative 4 times negative 2, or divided by negative 2, is positive 2. But here's where we have to pay attention. We just divided by a negative number on both sides, once again, on both sides. So what this means is we have to flip the inequality, meaning it's no longer going to be a less than symbol. it's going to be a greater than symbol. Okay? So in this case, we actually need y to be bigger than 2. All right? Now, you might be asking, well, why do we need to flip the inequality? Well, the way I normally like to describe it is, well, what happens when you multiply a number by a negative? Well, it flips its sign. It switches its sign. So if you multiply a positive number by a negative, well, the result's going to be a negative number. Same thing, if you multiply a negative number times a negative number, the result's going to flip and be a positive number. Okay? So it's the same kind of idea here, is if we divide or multiply by a negative number, it's going to flip the sign of whatever it is we're doing. So in this case, it's going to flip our less than sign to a greater than sign. And then everything just works exactly the same. We label what we can on our number line. We get y is greater than 2, so y cannot be 2, but it's anything that's bigger than 2, meaning 3, 4, 5, 6, 7. And you can double check that. Pick any number that's bigger than 2. Let's say 10. Negative 22, or negative 2 times 10 is negative 20. Negative 20 plus 22 is 2. 2 is less than 18. But if you pick something to the left of 2, let's say 0, negative 2 times 0 is 0. 0 plus 22 is 22. 22 is not less than 18. So that tells you the arrow has to go to the right. But the thing to not be lost here is this idea of flipping the inequality because we divided both sides by negative 2. And that negative 2 tells us we have to flip the inequality. And notice the difference between number 18 and number 20. Okay? Here we divided, but we divided by a positive number. Here we divided, but we divided by a negative number. So that's what we got to be aware of, and that's what tells us we flipped the inequality. So with that being said, I would take some time here based on what we just did right there to try a few of these on your own, okay? Preferably probably numbers 19, 21, and 22, because number 23, 24, and 25, those can be a little bit more difficult, a little trickier. But if you want to try them, go ahead. But I would suggest pausing the video, trying at least one or two of these out for your own, and then go through and check your work as you go. Okay. So let's go ahead and go back to number 19. Okay. If we look at number 19, just look at it like it's a two-step equation. And you can even, so like I did with the first one, you can even flip and switch this sign to be an equal sign if you need to. So that way you can clearly see what steps you need to do to solve this. But just for the sake of it, or just for the heck of it, I'm just going to keep it the same just so you can see. We can actually do it just the same with the less than or equal to symbol. Okay. Like I said, just treat this as an equal sign. So that's the two different sides of your inequality, and do everything you would do to solve the equation. Okay, so we have a over 5 is equal, or not equal to, and 12 over on the right-hand side. But then we need to ask, what should my sign be? Well, what did I just do? I added 6. I didn't even multiply or divide at all, so my sign should stay the same. Well, the next step is going to be to multiply times 5. Well, once again, over here we're going to get A. Over here we're going to get 60. And then we need to decide, well, what is my sign going to be? Well, in this case, what did I do? I multiplied, but did I multiply by a negative? Well, no, I multiplied by positive 5. So this is actually going to stay the same as less than or equal to. And then once again, we do those steps. We go over here. We have 60, 61, 62, 63, 64, 65, 59, 58, 57, 56, 55, and so on and so on, okay? So in this case, we go to 60. A can be 60, so it's going to be a closed circle. And we want the numbers that are less than 60, so our arrow is going to go to the left. And then once again, pick any number that's to the left of 60. One that's obviously left of 60 is 0, okay? Well, let's plug in 0. 0 over 5 is 0. 0 minus 6 is negative 6. Negative 6 is definitely less than positive 6. It's not equal to positive 6, but it is less than positive 6. So the arrow does need to point to the left. Number 21, very similar here. So just go through, solve it like you would any two-step equation. Oh, I about made a boo-boo there. So we are adding 11, so we need to subtract 11. So we get 7m over here, negative 42 on the right. So we need to ask, what's our symbol going to be, our inequality symbol? Well, we subtracted 11. We didn't multiply by negative 11. We didn't divide by negative 11. So in this case, my symbol should stay the same. And then the last step, we're dividing by positive 7. So here we get m. Over here we get negative 6. But this is a common place where people would say, oh, I flip it. I flip the inequality because I'm dividing. It's negative 42 over here, and I'm dividing it by 7. But you got to read carefully. It says if you multiply or divide by a negative number. Okay? Meaning, what did I divide by here? I divided by positive 7. Okay? So it didn't matter that this 42 was negative, so it's negative 42. What matters is, what did I divide the negative 42 by? I divided it by a positive 7. Okay? So that means, once again, my symbol should stay the same. So we go through the same thing. We label our number line. We're going to start at negative 6. M can be equal to negative 6, so we're going to have a closed circle. And we want numbers that are bigger than negative 6, and all those numbers are what's to the right of negative 6. Okay? So I just want to be very clear here. Every single step of solving an equation works exactly the same here. Okay? Whether it's a two-step equation, a one-step equation, a multi-step equation where you might have to simplify or simplify your expressions by either distributing or combining like terms, okay? It works with fractions. It works with decimals. It works with any type of equation we've done. It does technically work for square root equations, but once again, you don't have to deal with any square roots here with these type, at least in this class. That's something for a later math class that you can talk about, and how square roots affect inequalities, so how they can make it to where numbers can be bigger or smaller. But anyways, once again, every single step, notice my steps here to solve this two-step equation are the same that I use to solve any other two-step equation. The only difference is, you have to pay attention, and this is why writing down your steps is so important, that you have to pay attention to if you multiply or divide by a negative number. Okay? So when we go to number 22, if you're smart enough and clever enough, you can kind of look ahead and say, well, I see maybe something happening here, but let's just go through the steps. My first step would be to subtract 4. So I get W over negative 7. And then on the other side, we get 1. Well, I didn't divide or multiply by a 4 or a negative here, so all I did was subtract 4, so it's going to stay the same. But the next step, I'm going to have to multiply by -7. And if I multiply by -7, these -7s go away, so I get W. 1 times -7 is -7. But what should my sign be? Well, first off, I multiplied, so that's what I did here. I multiplied both sides. But what did I multiply by? A -7. Okay? So a -7, meaning this greater than symbol needs to flip and become a less than symbol. So once again, this right here tells us we need to flip. Okay, because we multiplied by -7. And once again, that negative is what tells us we needed to flip our inequality. So this is our final answer. And what does that mean? Well, how many solutions is this? Well, let's find out. It's actually, well, all of these are infinite solutions, but let's figure out what numbers are actually solutions. So let's label our number line. And make sure you do label your number lines correctly in terms of, especially with negatives, because negatives tend to trip people up with this. But in this case, the more negative the number, the smaller it is. So that's why you see it goes 7, 8, 9, 10, 11, 12 in the opposite direction, because all these are negative, okay? But in this case, we're going to have an open circle at -7, and we want numbers that are less than -7, so our arrow is going to go to the left. Once again, how do we know the arrow needs to go to the left? Well, because we had to flip our inequality, okay? Now, if you do get confused and you're not sure if you flipped it right or you should have flipped it or not, there is a check you can do, because if you didn't think you flipped it right, well, pick a number that's over here. I'm going to pick an easy one. I'm going to pick -14. It's on over here a little bit. But if I do -14 divided by -7, that's a +2. 2 plus 4 is 6, and 6 is bigger than 5. So that means my arrow's in the right direction. If it's not, we could have picked a number over here. So a big one, a nice one, is 0. 0 is to the right. Well, in this case, we would get 0 divided by -7, which is 0. 0 plus 4, which is 4. 4 is not equal to 5 or greater than 5. So that's why the arrow doesn't go to the right. And then we get to the tougher ones here, okay? And these are only tough because the equations, the inequalities themselves get tougher, so the steps get a little tougher. But once again, they all work the same way. So if you know how to solve an equation, no matter how you solve the equation, whether you have to, like in number 23, maybe flip terms around. So everybody can maybe see what I had to do with number 23 here. Is all I did was I flipped my terms around. So -3k plus 4. And now this one's going to work almost exactly like number 20, where we would subtract 4, get -3k over here, and -27 over here. Well, I just subtracted 4, so I didn't multiply or divide by anything, so I know my sign's not going to flip. But here I am going to divide by -3. So what that means is my sign has to flip. Okay, this part right here tells me my sign has to flip. Okay, because I divided by -3, -27 divided by -3 is a +9. And there's my answer. K is greater than or equal to 9. So 9, 10, 11, 12, 13, 14, 8, 7, 6, 5, 4. Well, 9, K can be 9, so we're going to have a closed circle. And we want the numbers that are bigger than 9, so that's all the numbers to the right of 9. Okay, but once again, how I knew that I flipped is I multiplied, in this case, actually I didn't multiply, I divided both sides. So divided by -3. And once again, the negative tells me I need to flip the inequality symbol. All right, then last two here, 24 and 25, can be a little tricky if you're rusty on these type of two-step equations, but the steps are still the same. Here I'm going to add 16, add 16. We get 3/8 x. I added 16, so my symbol's going to stay the same. -25 minus or plus 16 is -9. And then here we multiply, or in some cases you could think of divide by 3/8. But here we're going to multiply by 8/3. Okay, so the whole point of doing that is those go away, so we get x. We multiplied by a positive 8/3 on both sides, so that means our sign should stay the same. And then we've got negative times a positive is a negative. 9 times 8/3, a little tricky here, but we get 9 times 8 is 72 divided by 3. Let's see, that would be 24. So in this case, 9/8 times 3. Once again, if you have Desmos, you need to use that. -9 times 8/3 is -24. Now, don't get trapped into thinking, well, since the 9 is negative here, then the sign has to flip. We didn't multiply both sides by -9. We multiplied both sides by 8/3, a positive 8/3. Okay. Or if you went the route, we technically could divide by 3/8, but at the same time, I would be dividing by a positive 3/8. Regardless, that is my answer. Well, what does that mean my answers are? Well, it's anything on the number line when we label this out. 19, 5, -26, -27, -28, -29. So it's going to be anything not including 24. So 24 is going to be an open circle, or -24 is going to be an open circle, and anything to the left of -24, because we want numbers that are less than -24. This one's maybe a little bit harder to check, but just pick any numbers over here and plug them in. It doesn't matter which numbers you pick. Now you can be smart about it and maybe pick something like -32. Okay, if you can see that would work nicely with the 3/8. But the trick here is, and the key here is, same exact steps as solving any two-step equation, even with the fractions. Okay, and the only time, so in this case, the only reason we would need to flip is if that 3/8 was a negative. So if we had to multiply by a -8/3. Okay. And then we look at number 25. So I'm doing something here that maybe should help people out is think about this p plus 9 being in parentheses, because that whole thing is being divided by -4. So my actual first step here is actually to multiply times -4. Okay, so the whole point here, those will go away, so we get the p plus 9. Over here, -5 times -4 is a positive 20. This actually is an instance where we actually have to switch our sign now, okay? Because what did we just do? We multiplied by a -4, multiplied by a negative. So that means my less than symbol now has to become a greater than symbol, okay? And like I said, that's what you got to be on the lookout here. I multiplied times a -4. That means I have to flip the sign. I multiplied times a positive 8/3. I don't have to flip the sign. So I have to flip right here. If I don't, then my whole thing's going to be wrong, because now we see, well, what's the next step? Now it's actually to subtract 9. So P, we subtracted 9. It shouldn't change there, is greater than 11. And then once again, we just label our number line. Once again, label it as much as you can, just so it can be very clear what numbers, where you are on the number line, what numbers you're even talking about. So in this case, we're going to start at 11. So open circle at 11, and we want the numbers that are bigger than 11, so we go to the right. And that's pretty much it as far as solving inequalities go. Besides, so notice we didn't do any one-step inequalities. Notice we didn't do any multi-step inequalities, even though those are definitely something you could see, okay? Because, once again, the whole point here is if you know how to solve equations, you know how to solve inequalities, because it works exactly the same except the one thing. Like I said, this is the biggest thing. If you get nothing else out of this whole thing here, is this part right here. Okay? So write that down on your sheet. Make sure you copy that down somewhere. Make sure that when you have an inequality, that is on your mind, because that is the biggest thing about this, is if you ever multiply or divide, once again, it does have to be both sides, okay? So it has to be with the steps of solving the equation. If you have to distribute a negative, or if you have to, well, in that case, it's really the only time you'd multiply by a negative. But if you had to distribute a negative, or you had to divide just one side by a negative, it actually doesn't flip the sign. What matters is if you have to multiply or divide by a negative when you're solving the equation. So here we don't flip. Here we don't flip. Here we do flip because we divided by -2. Here we don't flip. We divided by 7. Okay? And this is, once again, why it's so important to write down your steps, so that way you know what steps you actually did. How did I get from here to here? Well, I subtracted 4. Well, that means I didn't multiply by a negative, or divide by a negative, so it stays the same. But what did I do to get from here to here? Well, I multiplied by a -7, so that means I have to flip. So you have to know your steps, okay? And you have to know what you did in those steps to really make sure and understand why or when you would flip your inequality symbol, okay? So with that being said, that's pretty much it for inequalities. Make sure do the homework, okay? As always, use these examples as guides for you. But like I said, none of this really matters unless you remember this, because I'll go ahead and tell you, if you forget to do this, then your question is going to be completely wrong. So your answer is going to be just completely the opposite way wrong. Because what happens if you don't flip the symbol is your arrow, so like with number 20 here, your arrow would actually be pointing the other way. And once again, that would be just a completely wrong answer, okay? That would mean that you would need numbers that were less than 2, and we could check. Put in 0. 0 plus 22 is not less than 18, so 0 cannot be an answer here, okay? So that means my arrow should not go to the left. My arrow needs to go to the right. And like I said, that's a way you can check yourself, is to make sure your arrow is going the right way. Just pick a random number, or pick a number that's easy to deal with. Notice I pick 0 a lot, because if I pick 0, then it usually makes my calculation pretty easy over here. Once again, 7 times 0 is 0. 0 plus 11 is 11. 11 is bigger than or equal to 31, so my arrow should point towards 0. Okay? But with all that being said, I know I went a little long there towards the end, but go through, practice with these. Make sure you do the homework. And as always, if you do have any questions, just let me know. But as always, thank you for watching.